Okay, good afternoon, everybody. Are you ready for your IGCSE workshop 2022? Why not? Okay, so I was hoping you guys would roar like this lion, you know? Yes? Cannot hear. Okay, today. All right, so what you have here is actually going to be some questions from past year papers that we're going to try to tackle today. Okay, we're going to try covering this. And then at the same time, I also have, okay, a few topics I would like to go through again briefly with you guys before you tackle the paper. All right, let's start. Okay, so first, let's talk a little bit about conservation. Because we previously remember last week,
we don't see any video
or 2 weeks ago, we talked about deforestation. What is deforestation? Anyone? Okay, let's call Isaac Young. Isaac Young, do you know what deforestation is? Cutting down trees. So we're cutting down forests. And what will that cause to animals and plants in that area? Because why would it be a lack of diversity? You're actually cutting down their homes. Imagine, guys, if I removed all your homes, where will you stay? Where will you eat? Okay, because you're human beings, you have some place, you know where to go. There will be help available for you. But for wild animals, right, they will be in danger. Can you pass your friends that just, wait, hold on, end the statement. And a lot more just came in. All right, so we have animals and plants that are being endangered and then getting extinct. So let's talk about some reasons why. Okay, these are all from the syllabus. You have to remember this. Question could be, explain why some species can become endangered or extinct. Then you give this, climate change. Okay, some animals, some plants, right, can't reproduce if it's too hot or it's too cold. So they're actually just happy with the temperature that they are accustomed to. Then suddenly when you have global warming, even with the increase of 1 to 2 degrees, right, especially in the water, your fishes, some of the fishes, right, they cannot reproduce very well. Or, all right, the water becomes too warm that their eggs actually do not grow and develop. Okay, then we also have habitat destruction because of deforestation, sometimes wildfires also. And we also have hunting. Anyone here has hunted before? No? Because in some countries, right, hunting is actually a sport. All right, during summer or autumn, they will take a gun and they'll go look for animals to kill, right, for sport. Now that could lead to, okay, the endangerment of species in that area, especially if it's like a very, it's a species that's threatened, like leopards and tigers and lions. Okay, you also have people hunting for rhinos. Why? Why would people hunt rhinos? Yeah, this horn, okay? What do they use it for? What is the rhino horn used for? Medicine. They believe that it has some medicinal qualities, and because of that, they kill the entire rhino just to get one horn. Okay, and rhinos, they are getting extinct because of this. Okay, another one is pollution. What sort of pollution? Water pollution would affect aquatic lifestyle, aquatic life. Even air pollution, you know. All right. Have you guys heard of acid rain? What causes acid rain? There's one gas that causes acid rain. Rian, what do you know about this? Certain gas that causes acid rain. Okay, haven't covered this yet, huh? Not CO2, but SO2, sulfur dioxide. Okay, so we have engines of our cars releasing out smoke and gas. All right, we have factories, they also release out smoke and gas. Now, some of the gases here is sulfur dioxide. And when it gets into the air, it mixes with the water. What will sulfur dioxide become? All your chemistry students. Sulfur dioxide plus water equals to what? Sulfur dioxide plus water. What is that going to become? Sulfuric acid. Sulfuric acid comes raining down. Acid rain. Okay, so this is dangerous for life, for the living things, because it either hurts the tree leaves or, okay, it will leach the minerals in the ground. You know, your aluminium in the ground, right? In the soil. As dissolve the aluminium and it will wash into the water. That's why the lakes, they will have aluminium. What will happen to the fishes if the water is has aluminium in it? They will die, okay? All right, so therefore, okay, this will cause endangerment to species and introduce species. All right, so can anyone tell me what animal this is? Okay, what sort of snake? I don't know if there's some really people that are into National Geographic, they can identify what kind of snake that is. Anaconda. Anaconda is bigger. This is a Burmese python. Burmese python. Burmese python actually comes from Myanmar, Thailand, Malaysia. You can find it in our region. But suddenly, right, they find this same python in US. How did it fly there? On a plane, is it? Okay, no. So what happens is some people, they keep this python as a pet. And then they don't want the python anymore because so boring. Look at it every day, just sleeping only. What did they do to the python? Some people, they release into the wild. Okay, here you go. Go back to your natural habitat. But in US, it's not the natural habitat of the Burmese python. So the Burmese python will be very vicious and they'll eat up all the animals there, leaving lesser food for other animals, other predators in that area. And because of that, right, they affect the whole food web in that area. Okay, so how can you conserve these? All right, so very quickly, you monitor, okay, you tag to see where did they move? How many of them are in this area? If they find that there's very few of them in this area, we have to protect this area so that this endangered species will grow in numbers. Okay, we will educate you guys, all you students, and the society, okay, to spread awareness of what animals are endangered. Don't kill these animals. Right? Of course, there's a lot more information for all this. Captive breeding. Has anyone heard about captive breeding? Okay, anyone seen the pandas in Zoo Negara? All right, they are actually part of a captive breeding program because pandas, they are quite endangered in the wilderness in China. So they will take pandas and they will keep them in like a safe haven, like that, like a captive breeding site. Okay, and then they will let these pandas breed. Hopefully they'll have babies. So they can protect these babies until they become adults. And then hopefully they will have more pandas offspring also. So in this way, right, while they cannot protect the species in the wild, at least they have some species in captivity so that the species will not be 100% extinct. So that's a captive breeding program. All right, and seed banks. Yeah, I know you guys do not really care about plants, but some of the plants actually, right, they are going to get endangered because of the climate change and everything. So what scientists will do is they will keep the seeds of these plants safe, and then they'll grow them, cultivate them, so that if this plant is extinct in a while or endangered in a while, at least they have some plants, some rare plants that they keep and then use that seed to further the species in the future. Okay, now let's go to question 1. Okay, open your papers, question 1. Okay, papers from 2022, you can see the code down here. All right. Okay, this is a very common question. Describe 2 pieces of evidence visible in these two figures, figure 5.1, 5.2, to show that these animals are mammals? Okay, answer. Again, see? They have hair. Hair is one. Okay, so I'll type it here for you guys. Hair, you can say fur also can. Just put one answer ni, hair, fur. What's one more? Now, remember they said visible. Visible means that you can see from these pictures. Don't give things like internal that you can't see. One more. Look. What are these? No. Their ears, okay? If you realize that all mammals actually have got external ears, can you tell me one mammal that doesn't have an external ear? Okay, so external ears. Another word for this, if you see, is pinna. Pinna is one ear, so you have two ears, pinnae. That's a scientific name for external ears. Do reptiles have ears? Do you see a snake have ears or not? What turtle? Okay, so they have ears, guys, but you can't see because they're not on the outside. They don't have like ear, you can't see them, it's not external. Their ears are on the inside. So they can still sense sound, but with internal ears. Okay, now the reason why I want to show you guys this and get you guys to try out this question is because of the graph. It's a very interesting graph. So have a look at your graph. Try to decipher the graph. Okay, what's so special about this graph? Where are the axes on this graph? How many y-axes are there? Okay, so there are two y-axes over here. So if you can see this, right, guys? Okay, let me coordinate a bit. There is number of Arabian onyx on this side. You can see 0 to 350. Okay, then on the other side, you have number of northern white rhinos, which is a different scale, guys. So they're trying to put to represent the data for both of these mammals in the same graph, so you can compare between them. And then the year. Okay, and then the key. How to read this? What's the solid line? Sean, what does the solid line represent? Sorry, say again? For the graph, you know that there's like a solid line here, and then there's a dotted line over here. Okay, what does the solid line represent? Look at the key. What does it represent? Which animal? Arabian oryx or the northern white rhino? Yes, okay, this is how you read this kind of graphs. This comes on IGCSE, which it did come in 2022 in February this year. Suddenly, your students haven't seen this, how to answer? Okay, this is how you answer it, all right? Okay, so that would represent the numbers for the Arabian oryx, which means that the dotted lines would represent what? Isaac Tam. Dotted lines represent what? Yes. Okay. Next question. Calculate the percentage increase. Now, we see a lot of this percentage increase questions. So you do this correctly, you can get 3 marks already, okay? Between these years, okay, let's see what are the informations that they want. If you feel that's very hard to understand what the question wants, you should underline the important information in the question. What animal are they asking us to find out? Chike? Okay, what year? Okay, so Arabian oryx is the solid line. Okay, let's do that. 1990 to 2000. Try that out. You got yourself first. Then we'll discuss the answer. First of all, if you have difficulty understanding how to read the scale, like if I have up here, if I have 2 boxes, what does that represent? All right, so you see here, there are 10 boxes here, 10 squares, representing 50. So you find that one box is going to be 50 divided by 10. One box will represent 5. So this number is going to represent what? Dorcas? What does this number represent? Sorry, what does this? This line here, okay. What number is that? Okay, good, 260. And then 190 will, the 1991 will be? Okay, which is right in the middle between 50 and 100. Finding percentage increase. $260. The largest number minus the smallest number, so that you can get your percentage increase. Sorry, you can get your increase over the original number. Which is the original number? You put in the starting number, the earlier number, which is 1990. That would be the original, times 100%. Okay, give your answers. Anyone with a calculator? Times 100%. Timothy, what's the answer? Do you have a calculator? No, okay. Who can answer? Jingjiang? Answers 247 degrees. That means that this oryx actually increased twice. Okay, more than 2.5 times. Okay, next question. Describe the data for the northern white rhino. Okay, northern white rhino would be the dotted line. So let's look at just the dotted line. Did they say anything else? Okay, so when you describe that data, number one, okay, we talked about this before. Let's repeat that a little bit. There will be the trend. Talk about the increase, decrease. Rapidly increase. Dave, wake up. Santosh, wake up. Okay, you're being recorded on camera here. Come. Wake him up. Okay, trend, increase, decrease. Okay, what else? Maximum, minimum. Okay, then what else? Give data. All right, so try this out for the northern white rhino. Right, what can you say? It's actually increasing. From what year to what year? Talk about the years. 1980 to 1995. From what values? You can say that straight away. From the values of 150 to, let me double check if I'm right. Okay, yes, I'm on the right line. Okay, to 250 rhinos. In about the year of, okay, what year is that? How do you tell? Okay, again, same thing. How do I tell what number this is? How many years is this? Not 5 years only? It is 5 years. I'm sorry. It is 5 years. Okay. And then there are 10 boxes here. So one box will become 0.5. So that means this one is 1996, 1997. So you state that in your answer. This is 1997, 250 rhinos. And then it increased even faster at a higher rate to this value here. Okay, what is this value? This is going to take a while. 320 in the year of 2000. And it's harder online. I think on paper you guys can help me. Guys, help me here. What year is that? Trini, what year is that? Do you know? If you don't know, you better figure it out right now. (2000 to 2005). One box is, 2 boxes would be 1 year. 2001, 2002, 2003. Over here, this is 2003. So all this data you can mention. Then after that, a big drop down. This is a steep decrease. Say that in your answers. Steep decrease. Okay, until what year? 2009. That's 75 also, right? About the 80. 80. Okay. Before a gradual decrease until 2020, what year, what value? So there's quite a lot of. Okay, am I making a mistake here, guys? Did you guys recognize that I made a mistake? Can you tell me what mistake that I made? Anyone tell me what mistake I made? I'm supposed to be finding out numbers of white rhino, right, guys? But which graph was I looking at just now? Which scale? I was looking at the scale of the Arabian oryx, which is totally wrong already. Did you guys do the same thing? Did you guys do the same thing? Okay, so learn from my mistake. What should you do, guys? Make sure you read from the right graph. Oh, okay. All right, read from the right graph. Okay, so all of it is wrong already. Be careful. Okay, so let me type the answers out. I'll show you guys the answer. I think it'll be faster. Okay, so remember I talked to you guys, I told you guys you have to start with a trend. There was an overall increase. There's an overall decrease in numbers. Well, we don't like, I mean, you can say that, but I would prefer to be safe because most of the questions will give this part of the answer. There would be an increase, and then after that, a decrease. So over here, you say that there is an increase from what year to what year, at what number? All right, and then there's a sharp decrease until 2020. Then you start giving the data. In 1980, there were 15 rhinos, which then it increased to 32 rhinos in 2003. This is how you can write it. Okay, you can even say that this was a maximum of 32, maximum number of 32 rhinos only. And then after that, a sharp decrease or steep decrease to 2 rhinos in 2020. All right, any form of data manipulation, like you want to count the rate per year, you can do that. And then the difference in rate of increase and decrease. Remember, we talked about steep and sharp, gradual increase. Okay, now these ones are what will be given marks for, okay? All right, guys? Okay, moving on. Try this one, we just discussed this. Suggest the conservation methods that were used to increase the number of Arabian oryx between 1978 to 2000. Do you recall? What are the ways to conserve? This one. Conservation, this one. Just talked about it just now. By monitoring and protecting the species and habitat of the oryx, having education to spread awareness about its endangerment, having captive breeding programs. Don't talk about the seed banks, because this is for plants. Seed banks for plants. Okay, so let's look at the answer so you know. So you can say that by providing protected areas for the oryx to breed in, to limit the hunting, limit the numbers, okay, of oryx that can be hunted per year. Okay, educating the society using breeding programs. Now, you choose 3 of these. Okay, question, guys. Did they tell you how many to give or not? Did they tell you how many to give over here? No, right? So that means, right, you can put as many as possible as you can remember, in case you're afraid that your answers may be wrong. Okay, so maybe you give 5, maybe the first 2 answers are wrong, you forgot about it, and you simply put in, but your last 3 answers are correct. So over here, what the examiner will do is the examiner will look through your entire answer for the correct keywords. Okay, so you can actually put more than 3 marks here. But you must make sure you can only do that if there's no number of answers stated here. Okay, if there's a number, then you have to follow the question. You follow instructions. Okay, skip this question. Let's go into the next one. All right, next one is population growth. All right, something new, a bit new for you guys, but let's do this one, cover this one, okay? So we talked about population, like, you know, you want to calculate, okay, in this area, how many, for example, this is like a new forest, and there's no rabbits over here, okay? So I decided like, oh, you know what? I think this would be a great place for the rabbits to come and live, okay? I release a male and a female rabbit here. And then off they go, hopping into the distance, but they're still staying within the same field. Next month I come back, I want to count how many rabbits there are. Every month I come back, I want to count how many rabbits there are in this area, whether they actually grew in population size or they actually decreased. Now, what do you think will affect the numbers that, you know, of these rabbits in this area? Lloyd? Yeah. What factors will affect the number of rabbits in this area? Whether there are more of them or lesser of them. Okay, you guys can see the information on the screen. First of all, if there's a lot of food, will there be more rabbits? Yes, less food. That means like maybe the vegetables are, you know, they didn't grow that well that season. There's less food, so there will be not enough food for the rabbits. So there will be lesser of them surviving. Okay, availability of food supply. And then we have predation. What's predation? Oh, I realized you cannot see my cursor. What's predation? Xavier, what's predation? Have you heard of the word predators? Okay, what does a predator do? Do you know? What does a predator do? Yes. Hunt animals, right? Eat animals, okay? So this rabbit, poor thing, okay? The eagles lah, you know, I don't know what, the foxes lah, they're all like so happy because you know what? They have new food to eat. So these rabbits are being predated upon. And because of that, the numbers will go up or down. Down, okay. But if there's lesser, like one day probably there's a disease that killed all the foxes in this area. What will happen to the number of rabbits? They will increase again, right? Okay, and then disease also. So 1, 2, 3, all right, will affect the growth rate of a population. And then you guys have to be familiar with this graph. All right, what does this graph show? Okay, don't look at the number of cells, okay? You can say, call this population number, and maybe this will be months. So maybe first month, there'll be just like a small rabbit still. It did increase, but it didn't increase a lot. Second month, wow, it increased a lot. So I'm going to show this on a Miro board because I want to do some information and notes on this, okay? All right, so here we are, okay? We can change this to population number. Number of cells could be population number, so whenever you read a graph, always look at the axis first. Don't look at the lines first. And then this will be time, months or years or even days. All right, so in the beginning, the rabbit number is very low. Okay, the number of rabbits very low. Okay, yeah, yellow will be better. Okay, then after that, suddenly you find that the numbers increase exponentially. Very fast growth. Okay, that's because there's enough food to eat. So when there's enough food, there's a lot of resources for them to survive. They will grow very well. But then when they get in number, like a lot of them, right? Like, okay, the rabbits grew in very fast, then after that, what's the problem that can happen? Andrea, what problems that can happen? Still have food, but there's lesser food. So if you see here, did the rabbits all die straight away? No, right? But you know what, guys? I'm answering my own question. But you can see that it's actually slowing down. The growth rate is slower. It's not as fast as before. Then after a while, it will become stationary. Stationary means that the number remains the same. Okay? And then, you know what? Maybe something that happens in this field, maybe there's a flood. Okay, or there was a fire that caused a lot of rabbits to die. And then when you went back the next month, you realized that, so few only. Population dropped down. All right, so therefore, guys, let's talk about this. In the beginning, this phase, we call it lag phase. Why is it that the numbers are low over here? Why are the numbers low? Any explanation? Cindy, what do you think? Question is, in the beginning, right, when the rabbit was being introduced to this area, why are the numbers low? Why didn't they suddenly become 100 rabbits within the next month? Possibly, they're like, I'm quite scared in this area. So, okay, possibly it takes time to adapt. Needs time to adapt to habitat and its environment. Number two, there's already very few of them. So definitely if they want to have offspring, right, it's going to take like a few months for the offspring to be born also. And you cannot imagine that they give birth to 100 offspring straight away. They can only give birth to probably 5. So in the beginning, right, the growth is very slow. Okay, number of, you guys can put notes for, write down notes for sir. So the lag phase of reproducing organisms are low. And then not just that, you let the rabbits run, they run into opposite ends of the forest, they cannot find each other when they want to reproduce. So they are widely dispersed. So it's very hard to find a mate. So that's why they don't reproduce a lot, because it's very hard to find a mate. Unless there are more of the rabbits, and everywhere you go, there's one rabbit there, you know, easy to find a mate. But here, in this forest, when there's so few of them, they're widely dispersed. Okay, hard to find a mate. Therefore, low rates of reproduction. So therefore, what happens to the population growth? It is very slow. Okay, if you can't get this, don't worry, later I'll sit on the Google Classroom. The birth rate versus death rate, which one will be higher? Birth rate or death rate? We don't talk about it yet. Why? Because in the beginning, I don't think not many of them are dying, okay? Or, okay, maybe you can say that if they did die, it is actually very low death rate and very low birth rate. Okay, but question, guys, if the population is increasing, it's going to be increasing, which one should be higher? Death rate or birth rate? Birth rate. Okay, if you want the population to increase, the birth rate needs to be higher. So in this case, that will be in this situation, that will be the case. Birth rate is higher than death rate. Okay, next one. Giving it some time, and there's a lot of food available, they suddenly increase a lot, exponentially. In this case, there's a name for this phase. What's the name of this? The log phase. Okay, think of your, I don't know, your ed math or what, when you learn log. Okay, explanation. Why does the population growth increase so fast? Okay, because there's abundance of food, sorry, too large. Abundance of food available. Okay, some more. Because there's so few of them, right? Possibly, their predators are so very low in numbers, okay? Low numbers of predators. And then not just that, okay? There are very few diseases. So they don't really die because of sickness. So in this case, birth rate and death rate, which one is higher? Birth rate will be higher than, okay. Birth rate is higher than death rate now. This one's important because, right, this will always be marked as mark when you mention it correctly. Ah, something's wrong already now. Okay, so this population growth will be exponential, okay? Population grows exponentially. That's why you can see that the graph here increases a lot. But then after some time, right, the growth rate will slow down. Okay, so here you can add in a bit more to your own graph there, your notes there. Growth rate slows down. Why? We talked about it just now. Not enough food. Okay, due to environmental resistance, that means the environment, right, is giving them problems. Okay, their habitat is giving them problems. Environmental resistance. Okay, due to limiting factors. Remember limiting factors? Okay, so the food supply is limited. What else is limited? Because there's so many of them, right? Their predators are even more happy because they got a lot of food to eat. So what will happen to the number of predators? Desiree, what will happen? It will increase. Okay, so number of predators are higher now. Predators increase, and because of that, right, they will eat more of the prey, causing the growth rate to be slower. And then not just that, because there's a lot of them, right, the disease can spread easily from one animal to another. Okay, same, right, like COVID. If everyone like groups so closely together, COVID can spread faster, right? So they're calling you to spread out and socially distance so that the spread of COVID will be slower. Okay, the same thing for disease in animals also. So this is for the purple line here, okay? Now, next comes the stationary phase. Okay, when there's so much problems from the environment, right? You can't expect that the numbers will keep going up higher and higher. So there will be a point of time that the numbers will not increase anymore. And this is called stationary. What's the meaning of stationary? What's the meaning of stationary, guys? There is no movement. Like your car remains stationary. No movement to the car. Why? Okay, the explanation is that, okay, now, this is the explanation, you explain this one. Because of the limited resources, birth rate and death rate, which is higher? They will be equal to each other. Is that what you said, Andrea? Right, the birth rate and death rate will be the same now. Okay, so when you see stationary phase, don't say that, oh, now no animal is born, no animal died. No, some animals died, some animals were born, but they kind of like balanced out each other, this birth and the death rate. Okay, so explanation here is that population number has reached the maximum has reached the maximum capacity that the habitat can sustain. That means this habitat is this size only. The amount of food is only this much. Okay, the amount of water is only this much. Environment, I don't know what else, oxygen is only this much, carbon dioxide is only this much, light intensity is only this much. Your population can grow as a plant or an animal, but it cannot grow more. Why? Sean, someone want to answer something? Okay, Sean, you want to say something? No? Why can't the population grow more than the number at the stationary phase? Anyone? Okay, because the answer for you guys, because the resources, right, can only sustain that number. And we have a special name for that number. It is called carrying capacity. Okay, so the carrying capacity this is the carrying capacity. We have a number called K for it. It's the maximum number that this population can go. So yes, the number may increase, but because there's not enough food, it will decrease. When the number decreases, there's some food available, so the number will increase back again. So the actual numbers are actually fluctuating, but they will be averaging at this particular carrying capacity. All right. Then usually, right, the numbers, if nothing changes, the stationary phase will last forever. Okay, but we always know that there will always be something that comes that changes things, right? So what could be a problem that this entire ecosystem can face? Anwen, what do you think? Anwen, what do you think? Do you hear my question? No. Okay, you listen carefully, right? How are the girls? All right, Trini, what do you think? What's my question? What is one thing that can happen, okay, to affect this entire ecosystem and this habitat that can cause the animal or the plant population to go down like this suddenly? Again? Again? Food. What about the food? Possibly can say that there was suddenly something that happened like a drought, that there's no food that grew. Or there was a fire, so all the food was wiped, all the plants were wiped out. Okay, so because of an event, right, it caused the numbers to go down because, okay, it caused the numbers to go down. And this is what we can call the death phase of that population. Okay, what happened? Okay. A sudden change maybe you can say climate change, okay, or maybe you can say humans come in and cut down the forest, okay, deforestation. This is one of the reasons. Okay, what about that? Disease, a new disease that wiped out the whole population. Okay, what else? Natural disasters. Like a fire, a flood, a drought. Okay, that will cause what to happen? I wrote them all here already. Okay. So when this happens, the death phase, which one will be higher, birth rate or death rate? So you say that the birth rate is now lower than the death, and that caused the drop in the population. Population decreases. What will happen if nothing is done and the population keeps going down, 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 down? What will, if nothing is done, okay, and the death phase keeps going, what will happen? Yes, extinction of that species in that area can happen. So either we help them, okay, or something changes and improves in the environment so that suddenly there's more food available, no more disease, temperature goes back to normal, the habitat grows, the trees, or they grow very fast, and slowly you will see that the numbers will increase after that. Okay, so, whoops, okay. Yeah, better not draw. Slowly, the numbers will increase after that. Guys, this is the population growth. Okay, now go back to your papers now. Question 2. Okay, let's try that one out. Okay, in question 2, let's start with this question, the one that we just discussed. All right, if you read the beginning of this question, they're talking about bacteria. And then we talked about this before, guys. Growing the bacteria in a fermenter, right? Okay. So this is a form of laboratory fermenter. Usually the actual one is a big silver capsule. But then this one is one in the laboratory. They're trying to grow this bacteria. Can we start with question B? I think we start with question B. Explain why a source of nitrogen and glucose is added to the fermenter. What's nitrogen for and what's glucose for? Why must we give it to the bacteria? Anwan, what do you think? Okay. Nitrogen. Why must we give nitrogen to the bacteria? Anwan, do you know? No. Okay. How about glucose? What is glucose needed for? Maybe someone can give the answer? Does anyone know what glucose is used for? It's a source of energy, right? That's why we must give some glucose. Because we want this bacteria to grow in numbers, they must have energy to... Hello, everybody. Sorry, just now there was a technical issue. Hope you can hear me now. Those online? Can hear? Yeah, thank you so much. All right, so we're going to move on. Samples were taken from the fermenter at frequent intervals because they wanted to count the number of bacteria. All right, so if you see here, exactly like what we discussed just now, but this one is not about rabbits, it's about bacteria. Explain what happens at A, B, C, and D. So y'all can try these questions and realize that it's actually a 6-mark answer. It's like an essay, so difficult. What to write? Well, guys, if you have written exactly what we talked about just now, guarantee you there will be something here that can help you, okay? All right, so this one is talking about in the wilderness. But, all right, you will be able to try to adapt it to bacteria population. Okay, let's talk about A. First of all, here's what you can do, guys. You can talk about the phase. What is the name of the phase? Because they're asking you, what happens? Okay, so you can talk about the phase. You can talk about the reason. You can talk about the number. You can use data, even though they didn't mention that you have to mention to use data. You can use data over here, okay, for your answers. Population growth. Yeah. Okay, I'll just rewrite that. Okay, you can talk about the birth rate and death rate. This reason, right, talk about the differences between the birth rate and death rate, because this is always going to be marked, given, it's going to score you here. Okay, let's talk about A first. What phase is A? Lag phase. A is a lag phase. What's happening at the lag phase? Bacteria is growing fast or slow? Bacteria population is growing, yes, but it's growing slowly, not fast. Why do you think it's growing slowly? Okay, Jingxiang, why do you think it's growing slowly? Yes, you're actually explaining but the reason of why the bacteria population is growing slowly. Very good, okay. Bacteria is adjusting to the conditions in the fermenter. Then you can talk about B. B is what phase is that? Not the death phase. Death phase is D, when they're dying and the number's growing it's dropping down. No. Sorry? It's a log phase, thank you. Okay, what's happening there? Bacteria population is growing, not growing or decreasing? Growing, but slowly or exponentially? Remember the word exponentially. You can use that. Yes, Trini? Okay. Can you see? Can you see closer, because I can't zoom so big. Okay. All right. Bacteria is growing exponentially. Now, reasons. Why do you think that it's growing so fast? Aaron. Again? Okay, it's adapted, but okay. And then what else is, why is it growing? It's adapted, and then what else is available for it? Ah, okay, so you have a lot of food available for it. Food is abundant because there's not many of them to eat, and there's a lot more food than them. So if you're like, not sure what to write, okay, you can write this. And remember, we talked about the death rate and birth rate. Food is abundant. All right, what happens to the birth rate and death rate? Versus the death rate. Birth rate is higher or lower? Higher than death rate. Okay, next. C. Let's look at what C is. What kind of phrase is that? Numbers not moving anywhere, so it's like stationary. Okay, what happens to the bacteria's population? Stagnant. Okay, you can say stagnant. You can say does not change. Any reason for that? What about the birth rate and the death rate? Equal, okay, it's equal or the same. So you choose one answer here. It's either the birth rate is equal to the death rate, or the birth rate is the same as the death rate. Equal to, same as the death rate. So the number doesn't increase. But it doesn't mean that nothing is born or nothing is dying, okay? Okay, and D. Suddenly you decided like, okay, let's just heat up the bacteria in this fermenter and let's see what happens to the population. Then you heat it up straight away, the bacteria goes like that because they're all denatured. Okay, D, what's that? What kind of phase is that? Death phase. What happens in the death phase? Bacteria population increases? Stays the same? What is it? Decreases. Okay, now talk about the birth and the death rate. Birth rate is what? Lower than the rate. Because I didn't hear it. No. Okay. Reason why? Reason why? You know what? The ones online? Okay, questions on the screen. But let's do the teaching part first. Actually, we don't have much time, but let's go into the teaching part first to refresh our memory on genetic engineering, okay? So number one, we must identify which gene that we want to take first. Which gene would code for maybe say making insulin? Identify it, locate it, and then over here, remove it, and then cut it. All right, so we go quick on this. The gene is cut from the DNA strand using restriction enzymes. So you must remember what sort of enzymes are used. When the restriction enzymes are used, okay, they will leave not a straight cut, but a sticky end. What's this sticky end? Like this. It will not be a straight cut, but it's like a jigsaw puzzle, you know, like this. Okay, it will leave this kind of shape for it to lock onto the other part later. That's your sticky end. And then at the same time, once you cut that out, you also at the same time go take out a plasmid from a bacteria. And then use the same restriction enzyme yeah, sorry, you can't see. I'll zoom in. Wait, hold on. Leaving complementary sticky ends. Sticky ends, word for the day. These are the sticky ends you see there? Because of the same restriction enzymes, they should fit together. And then you're going to take this and then you're going to stick it in. What enzyme are we going to use to stick this in? Ligase enzyme, yes. It's like the glue. The cut ends of the plasmid is joined together with the human DNA. Okay, see how it fits like a jigsaw puzzle with an enzyme ligase. So all these enzymes are really important to remember. And then therefore, after that, your recombinant plasmid, this is your recombinant plasmid, is inserted into another bacteria. And then your bacteria will divide and copy this. And then it will make many copies of it. So you don't have to do so much work later. You just do the work. I mean, you just do whatever that is needed to join them together, create a plasmid. And then your bacteria will copy it for you by mitosis. Okay, so I got to pause here because I think your teacher needs to, the next teacher needs to come in and set up. But those online, I'd like to say that if you want these papers, okay, I think I can make it available for you. Just let me coordinate with the school, and then we can send this to you in PDF file, and then you can answer this. There's some hand-picked questions for you guys. So thank you very much for listening, and all of you guys for being here.